Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, welcome back to my YouTube channel. My name is Aliyah Rumini Larasati, with my ID number is 4192111004. Today, I will continue the discussion from the previous video. I will explain what I know in the chapter 6, namely about Egyptian mathematics development. Mathematic Egypt refers to the mathematics written in Egyptian. Since the Hellenistic civilization, Greece replaced Egyptian as the written language for the educated Egyptian. And since then, Egyptian mathematics focused with Greek and Babylonian mathematics, which gave rise to Hellenistic mathematics. Mathematical studies in Egypt continues below Islamic Caliphate as part of Islamic mathematics. When Arabic became the written language of the educated Egyptian, at that time mathematics also developed rapidly. This happened because mathematical knowledge was indispensable in measuring and making maps, measuring for building construction, and etc. In teaching mathematics in this field, look for the study numbers, size, fields, and etc. until he found a way to count the measure the object. Then he made a measurement or count formula which was then written in an exhibition or a roll of paper from papyrus bark, so that in teaching people who study it were easier to understand and faster. Civilization reached a high level in Egypt at an early period. The country was well suited for the people, with a fertile and thanks to the river Nile, yet with a pleasing climate. It was also a country which was easily defined, having few natural neighbors. To attack it for the surrounding desert provided a natural barrier to invading force. As a consequence, Egypt enjoyed long periods of its when society advanced rapidly. By 3000 BC, two earlier nations had joined to form a single Egyptian nation under a single ruler. Agricultural had been developed, making heavy use of the regular wet and dry periods of the year. The Nile flowed during the rainy season, providing fertile land with complex irrigation system made fertile for growing crops. Knowing when the rainy season was about to arrive was vital, and the study of astronomy developed to provide calendar information. The large area covered by the Egyptian nation required complex administration, a system of tax and realms had to be supported. As the society became more complex, records required to be kept and computation done as the people bartered their goods. A need for containing arose, then writing and numerals were needed to record transactions. By 3000 BC, the Egyptians had already developed their hieroglyphic writing. We can see our article Egyptian numerals for some more details. This marked the beginning of the Old Kingdom period during which the pyramids were built. For example, the Great Pyramid at Giza was built around 2650 BC, and it is a remarkable feat of engineering. This provides the clearest of indication that the society of that period had reached a high level of excitement. Hieroglyphic for writing and counting gave way to a hierarchic script for both writing and numerals. Details of the numerals themselves are given in Egyptian numeral. Here we are concerned with the arithmetical method which they divide to work with these numerals. The Egyptian number system were not well suited for arithmetical calculation. We are still today familiar with Roman numerals, and so it is easy to understand that although addition of Roman numerals is quite satisfactory, multiplication and division are essentially impossible. The Egyptian system had similar drawbacks to that of Roman numerals. However, the Egyptians were very practical in their approach to mathematics, and their trade record that they could deal in fraction. Trade also required multiplication and division to be possible, so they devised remarkable methods to overcome the division in the number system with, with which that had to work. Basically, they had to devise methods of multiplication and division which only involved addition. Early hieroglyphic numerals can be found on temples, stone monuments, and feasts. They give little knowledge about any mathematical calculation, which might have been done with the number system. While these hieroglyphs were being carved in stone, there was no need to develop symbols, which could be written more quickly. However, once the Egyptians began to use flaxen sheet of the dry papyrus and the tip of a pen, there was reason to develop more rapid means of writing. This prompted the development of hieratic writing and numerals. There must have been a large number of papyri, many dealing with mathematics in one form or another. But sadly, since the material is rather fragile, almost all have various. It's remarkable that any have survived at all, and that they have a consequence of the dry climatic condition in Egypt. Two major mathematical documents serve. You can see an example of exemption mathematics written on the Rian papyrus and another papyrus, Moscow papyrus, with a translation in hieroglyphic script. It is from these two documents that most of our knowledge about Egyptian mathematics comes, and most of the mathematical information in this is taken from these two ancient documents. Here is the Rihan papyrus. The Rihan papyrus is named after the Zoltis civilization, a Henry Ryan, who purchased it in Luxor in 1858. The papyrus, a scroll about 6 meters long and 1 per 3 of meter wide, was written around 1650 BC by the scribe Ahmad, who stated that he is copying a document which is 2 years older. 200 years older. The original papyrus on which the Ryan papyrus is based therefore dates from about 1850 BC. The very long Egyptian mathematical text, the Ryan Gazette, something referred to as Ahmad Gazette because it is older, is dated to 1650 BC, but is probably a copy of an older Middle Kingdom document from 2000 until 1600 BC. Sheet is an instruction manual for students of arithmetic and geometry. In addition, the providing area formulas and methods for multiplication, division, and working with fraction. The sheet is also evidence for other mathematical signs, including composite number and prime, arithmetic, geometric, and harmonic average. The sheet also contains how to solve linear equation first order, as well as arithmetic and geometric sequence. Also, the three geometric elements inscribed in the Ryan set, implying a very simple discussion of analytic geometry. First, how to get approximation which is less than 1% accurate. Second, the attempt to square the circle. And third, the areas with use called tangen. And then here is the Moscow papyrus. The Moscow papyrus also dates from this time. It is now becoming more common to call the Ryan papyrus after Ahmad rather than Ryan, since it seems much fairer to name it after the scribe than after the man who purchased it comparatively recently. The same is not possible for the Moscow Papyrus. However, science sadly the scribe who worked this document has not recorded his name. It's often called the Golensiev Papyrus after the man who forecast it. The Moscow Papyrus is now in the Museum of Fine Arts in Moscow, while the Ryan Papyrus is in the British Museum in London. Another important Egyptian mathematical text is the Moscow sheet, also from the Middle Kingdom area, dated to 1890 BC. This manuscript contains word problems or story equations, which may be intended for entertainment. One problem is considered to have special needs because it provides a method for obtaining volume pyramid behavior. Finally, the Berlin tablets show that the ancient Egyptians were able to solve second-order algebraic equations. The Ryan Papyrus contains at least 7 problems, while the Moscow Papyrus contains 25 problems. The problems are mostly practical, but a few are posed to teach manipulation of the number system itself without a practical application in mind. Reaching in discuss that problems of their division of lobes which were particularly important in the development of Egyptian mathematics. Some problems ask for the solution of an equation. For example, a round field has diameter 9 cat. What is its area? The Moscow Papyrus also contains geometrical problems. Unlike the Greek, who talk abstractly about mathematical ideas, the Egyptians were only concerned with practical arithmetic. Most historians believe that the Egyptians did not think of numbers as abstract quantities, but always talk of a specific collection of egg object when egg was mentioned. To overcome the deficiency of their system of numerals, the Egyptians devised cunning ways around the fact that their numbers were purely suited for multiplication as is shown in the Ryan Papyrus. We explaining in detail in mathematics content in the Egyptian papyri in a separate article Mathematics in Egyptian papyri. In this article, we next examine some claims regarding mathematical content used in the construction of the pyramid, in particular the Great Pyramid at Giza, which as we note above was built around 2950 BC. Finally, we examine some detail for the ancient Egyptian calendar. As we mentioned above, it was important for the Egyptians to know when the Nile would flood, and so this required calendar calculation. The beginning of the year was chosen as the heliacal rising of Sirius, the brightest star in the sky. The heliacal rising is the first appearance of the star after the period when it is too close to the sun to be seen. From Sirius, this occurs in July, and this was taken to be the first of the year. The Nile flowed shortly after this, so it was a natural beginning for the year. The Egyptian calendar, although changed much over time, was the basic for the Julian and Gregorian calendars. Okay, I think that's all I can explain in the chapter 6, namely about the Egyptian mathematic development. If I have something mistake and then I have mistake in my pronunciation, please apologize me, and then thank you for your attention. Thank you for watching. See you in the next video. See you in the next capture. Goodbye. Wassalamualaikum warahmatullahi wabarakatuh.